Hello, I'm Szymon Brandys, so I work for IBM company in Krakow, and today I will try to introduce you to something called prescriptive analytics. And this is, I will use IBM platform that is publicly available. So after the presentation, you will be able to play with all these examples that I show today. But first, I would like to introduce a couple of concepts to better understand what this prescriptive analytics or this optimization is. So basically, prescriptive analytics is about making smarter decisions. Is about creating better schedules. Basically, in the industry, prescriptive analytics is about getting the most from the resources you have and use them in the best possible way. And this is a slide showing some examples, and this is a comparison between predictive models or predictive models approach and prescriptive models. So you can see a couple of categories here. And basically, predictive models are, this can be machine learning models, for instance. And let's maybe look at the HR category, where predicting models can be used to, predict or forecast some employee retention, while prescriptive models or optimization models can be used, when we know what the projected retention is, we could plan some trainings or compensations to change the retention, and basically these models can be used to make an optimal plan for such thing. And so basically, in prescriptive analytics, the main question we ask is what should we do, right? So or how we should use our resources to make to get an optimal outcome. And the next concept that I would like to introduce is optimization problem. So basically, in optimization problems, the basic idea is the same. So basically, we have some value we want to maximize or minimize, and we have some constraints that we need to fulfill. And a very basic example is constructing a rectangular garden, where we have, what we want to achieve, what we want to maximize is the total garden area, while the constraint may be the length of the available fencing. And if you are, let's say, interested in what kind of optimization problems we have, some of you probably are aware of them, but there is a lot of web pages where you can find other problems, and then, well, maybe you can try to solve them using our stuff in the IBM data platform. And maybe another example is going again to our HR example. So the optimization problem in this area could be we want to plan some trainings, and the value to minimize in this case would be the budget, while the constraints can be the time, number of trainings, I don't know, number of people on the training, stuff like that, right? So this is the optimization problem, and usually to create the model, the model is basically some mathematical formulas, and in the past it was not easy to create such a model. So basically, you had some specialists working just on these models. It's called constraint programming or mathematical programming. So there were some special languages to do it. Later, there were some libraries added to Python libraries or some for other languages, and you could write such a model, but it was still a bit complicated. So it's not an easy thing to do, or maybe not hard, but basically not for everyone. And And the question here, and I will try to answer that question, is if we can build such a model without writing these mathematical formulas, in an easy way. So everyone, let's say, can write it. And actually, the answer is yes. This is part of the UI that I will try to show you during the demo. This modeling assistant. So we will be using that on data platform, this IBM data platform. So and maybe just two things because we will be using them. So first is IBM Cloud. We will use it. So this is basically a platform that combines, PaaS and IaaS solutions. So you can deploy your applications using Kubernetes, OpenShift, Cloud Foundry, and stuff like that. So this this could be useful. I don't know if we have enough time to go that far, but maybe we can go to using IBM Cloud. And the next thing is Cloud Pak for Data. So this is this IBM data platform that I mentioned. And basically, this platform allows to process your data, to create models, both machine learning and these decision optimization models, create visualizations, dashboards, and stuff like that. So we'll be using this stuff. And and basically, the idea would be to create an application like this. I think that we will go, I don't know if we go to the Node.js application, but we will try to use Cloud Pak for Data for, project collaboration, creating the model. And we will use decision optimization engine to run the model and see the results. And and now the demo. So I will switch to my browser now. And so this is the, let's say, the main dashboard when you enter the data platform, this Cloud Pak for Data. So let me start from creating a project. And by the way, this is free, right? So if you want to follow or you want to try it later, as I mentioned, this is, you can do it for free to some degree. But I think the model that I'm showing you right now, you should be able to create it. So so I will show you the first example, let's say from the scratch, and other examples will be that are evolution of the first example. I have them pre-created because I want to save some time. So let me create an empty project. Where's my okay, here it is. So let's call it sandbox. So not 3, 4. Okay. So I will not explain all the concepts or everything that I'm doing, because we don't have enough time. But what you need to know is that we have a project that we can create. We can collaborate on the project. So if you want to add someone, you have access control and stuff like that. And we have a concept of assets. So you can add data, some models, dashboards. But the model that we want to add is the decision optimization model. Let's call it experiment 0. And I mentioned at the beginning that our models use there are some common parts between models, machine learning models and decision optimization models. So basically, we use the same engine underneath. So, but as I said, I don't want to go into details. So I just need to assign it. So the model is. So the model is when created, it needs to have this machine learning instance associated with it. So okay, so this is the UI for development the model. So the problem that I will try to solve here is let me maybe import the data first. because the topic, the subject of the presentation is optimizing schedules, right? So so this is the problem that I'm trying to solve. So right now, let's start from something pretty simple. So I have some tasks, and I have each task has some duration in hours, and we have CPUs, which are, let's say, processing units, and the idea is that these CPUs will process these tasks, and in the past, or for some experienced user, you would have to create a model in Python or some other language, as I mentioned, with some complicated mathematical formulas. But what we have in this CP Cloud Pak for Data is modeling assistant. So when you use it, it will allow you to create the model using, let's say, natural language. There are a couple domain, but we want to use scheduling. And if you try it yourself, everything is pretty well described here. So you have lots of informations, but basically what you need to know for now is that for the scheduling problem, you need to choose what is your tasks table. So basically, this as you can see, this is something that we would like to create schedule for. So in my case, it's tasks, and resources is basically the processing thing, right? So if you look at the tooltips, it describes the example it's using is home building, I think. So basically, tasks can be some house building activities like carpentry or something, and resources can be basically the workers, right, doing these activities. So yeah, let's go. Let's continue. And basically, you will have this model created. So you have this. You see this, let's say, natural language representation of the model. So basically, for free, you are getting the model that will minimize the complete time of all tasks. You have some implicit rules, which are where the tasks start, when the whole all these activity starts, and you just need to set a couple things that are highlighted in yellow. So basically, you just need to point at the let's say, column in the tasks table that represents the duration of the task. So I will, and it's values in hours. And here you have some extra information. You have some suggestions, so you can look at what other constraint can be added. You have some settings. What is important here? I need to change it to hours. And you have data schema. So basically, when I chose this tasks table and CPUs table, this mechanism processed it and assigned some information to each table. So it found what is the primary key of the table, what are the type of elements in the columns and stuff like that. So basically, we have the first model created. We can run it, and what we are expecting is that we will get. Okay, so it takes some time, like, I don't know, less than a minute for this small model. But basically, what we expect to get is the schedule, right? So all the tasks, what is the sequence of how to run this task on each of these two CPUs. So let's see, let's wait a couple seconds. Yeah, so you have this nice chart showing, okay, so, well, maybe let's start from the engine statistics because you already saw this chart. So the chart shows how, because this optimization, let's say there are some couple steps, right? So over time, it finds a better solution. So and basically, you see two lines here. So this lower line is something that we call best bound, and this best bound is projected best value. So this is something that the engine, based on the input data, well, thinks or finds as the best solution. So it says that probably 12 is the best value, and we will not go below that. And this violet line is the real, let's say, objective that we found, and we created a schedule for it. So in the results, we have also solution tables. So this is basically all tasks and all the information when each task is started and ended, and what is the sequence of the tasks. And if we go to visualization, right now it's empty, but for the scheduling problems, we can add Gantt chart, and it will visualize, the schedule, right? So I think that in model, one of the constraints was that it starts at 1 something p.m. and then you see how these tasks are run in parallel on these 2 CPUs. So this is the first model, so pretty easy. And let me go to the next, let's say, evolved version. So in this evolved version, we still have tasks and CPUs. But this time we have a new column in tasks that is called preceding tasks. So basically, some of tasks have to be run before others, right? So in this case, we have task 5 that needs task 3 to be run first. And for task 1 and 2, we need task 5 run first. And when you go to the model, I already have this rule: each task starts after the end of preceding task. But basically, well, let me remove it. If I do something like that, so it will try to suggest something that matches these preceding tasks, and I think that somewhere here if you will have so this is, well, maybe not perfect, but each task starts after the end of the predecessor. So this is how you can find the constraints, right? So here it suggests that you should choose some predecessor, and basically I'm choosing the column that contains the task name. And right now, if I run the model, well, it's already run, so it doesn't make sense to waste time. So again, I'm getting solution tables, objectives. This combined objective, by the way, I didn't mention, but this is basically the number of days for all tasks to run. And if I go to visualization, it shows our tasks, and you see that they are a bit, the sequence of these tasks is a bit different. So if you look at the table with tasks, you will see that based on this table, the first task that should be run is task 5. And sorry, not task 5, task 3, right? So task 3, so it's run. Task 6, here, task 6 has no preceding task. So basically you can see that you have tasks 3, task 5, then task 1 and 2 are run after this task 5, right? And other tasks have no preceding tasks, so they basically are just added somewhere in this sequence. And so this is like the more evolved version of the schedule. And the next one is the next version. The next version of the model is of the problem is where we have an extra table, and basically, in addition to the preceding tasks, we define something called size. So basically, we say that each task can have some size, and we have this special table just to, well, define the size, like integer value for the size. And each task can have this size, and also CPU can have size. And the change that we have in the model compared to the previous example is we still have this each task starts after the end of preceding tasks, but we also added this for each CPU task assignment. Value of size of assigned task is less than or equal to value of size of assigned CPU. So it means that for each task, we need to have at least CPU that have the size at least the same or bigger, right, than the task size. So yeah, so I already ran the model. So if we go to export solution, you will see combine objective 22. So this is for the solution that we found. We have whole operation or all activities, all tasks will run into 22 hours. And of course, we have solution tables. And if we go to visualization to see the Gantt, you will see it's a bit different. So let me open the table with data again. So you will see that we have two CPUs, one is small, one is large. And basically we have two tasks that are large. So so task 1 and task 2 can be run only on the CPU 2, right? So and tasks 5 and 6 can be run only on CPU 1. So basically, if you look at it, this is what is in the schedule, right? So you have task 6 running on CPU 1, so it's okay. Then you have the precedence set correctly. So that's how it works. And of course, let me go to run model again. So you can add more rules. So well, starting from this, you can just start experimenting. You can, for instance, add just as an experiment, you can see. Yeah. So, for instance, it's. So there are rules like, you can disable particular resource, right? So you can, for instance, go here and disable. I think this should work. CPU 1. So I'm disabling CPU 1 right now. So this is my new constraint. And if I run it, so CPU 1, sorry, let me check. CPU 1 is the small one, right? So I'm leaving just the large one. So let me run it. So let me run it. So right now you should see just one line when, yeah, okay. So it will take some time, but right now in the Gantt chart you will see probably just one line on CPU 2 because CPU 1 is disabled. So you can do such experiments. You can add more tables and try to make the model more complicated. So this is how the model can be developed. So let me just see what we see in the visualization. Okay. Yeah. So as I said, right. So you have just one line and just one CPU is used in the new schedule. So this is how the model is developed, right? So basically, you can do experiments. You can try to find the best model, and the next step would be to somehow use this model in your application. So what you can do as the next step is when you have the model created, there is a sequence of steps that are described in the documentation. So basically, if you don't follow all the steps that I'm showing right now, you can go to data platform cloud.ibm.com docs, and just if this presentation is recorded, you can just find the URL and just go through this procedure. And but basically, sorry, this one, right? So basically, there is a sequence of steps you need to do now. It's saving the model for deployment, and so let's see. So right now the model is basically exported, so it can be used to deploy a new service that can be used by your applications. So it's here. That's so you can see that the structure of the models. You can see there is this input schema, output schema. Input is basically created based on on these tables, right, that were in the model, the third version of the model. And now you can promote it to deployment space. Sorry, I will not explain what is the deployment space, but basically this is some space where you can store the data that are run by the deployed model. But okay, so select create space. Okay, so let me create a new space. So it's all explained in this documentation, right? So let me just go through it and just take it for granted right now. Yeah, so basically you are creating you are saving a model, then you create the deployment, and then you create a job. So let me switch to example that I already created because it will be quicker. Oh, sorry. So basically, when you go through all these steps described in the documentation, you will end up with having a deployment with some jobs, and there will be a default job and the job I created. And the job that I created basically runs the deployment, and it can be scheduled. So for instance, if you just want to have some scheduled operations that are run like daily or weekly, and you just want to find what is the best, let's say, schedule for a day, for this particular day, it will be run, first some schedule, or you can run it. So basically, it will give you the new optimized schedule in this case. Okay, but what is more important is this second job that I created. Sorry, the one that is created by default, actually. I mean, this one. Yeah. So because this job basically can be used to make a REST calls, right? So basically, I need to do a couple things here. It's all, as I said, described in the documentation. So I need to create an access token for my service. So this access token will will, let's say, it's just a temporary token, so you will do nothing interesting with it if you copy it. Okay, so this is basically some REST code that you can use in your application UI or something, and you see that you call this job, right? That is, I will open it here. Yeah, okay. So we have this job with the model, and then we have here, and then we have this endpoint. We can pass some some payload, and basically this payload is similar to, this is a JSON representation of this CSV tables that you saw when I was building the model. So you can put whatever you want here, right? So basically in your application you can send some data from the application, then you send it. It starts the job, I hope. Okay, so it's starting. So basically, what's happening now is the model that I created as experiment 3. So I deploy that, and when I call this this endpoint, I'm sending new data to the model. The model is solving it, and later, because this is it may be a long-running operation, I can retrieve the result by querying the job. And here I have the results, which is the similar format, but in JSON. What I get here in this UI, right? So, and I can create my own application with my own Gantt chart for my customers, or I don't know, for someone. So basically, the next step would be to create an application, deploy that in cloud, and start using these REST calls to get this data. But yeah, so I don't think I have time for it. So and give me a second. So this is the end of the demo. Let me just go back to the slides and yeah. So the example I showed you is just one of the examples that we have ready. So if you would like to see others, there is a IBM decision optimization organization on GitHub with more samples. You can see them here, right? So you can try them and see other kind of problems, because speed scheduling is also a scheduling problem, but diet is different kind of problem that we may optimize. So diet is, for instance, to optimize the meals to get enough nutrition or something like that. So so this is another example you can try, and that would be it. So I'm waiting for some questions if you have anything. I will try to be on Discord later, but if there are some questions that I'm not able to answer right now, but let's try. Thank you. So going back to studio, right? So